Hi, everyone. Thanks for being here for one of these last talks of the day. It's been a long day, a lot of presentations and sessions that you all have been at, so we appreciate you being here with us. We're going to try and keep it light and kind of casual at our talk, which is Addons Need Love 2, Increasing Cluster Security Through Addon Maintenance. So we are your presenters. My name is Stevie Caldwell. I am a tech lead for the SRE team at Fairwinds. If you don't know what Fairwinds is, and if you don't, why? We are a company that builds and maintains Kubernetes clusters and the underlying infrastructure on which they run.
And I'm Andy Suderman. I am the CTO at Fairwinds. Stevie's my boss. I am a CNCF ambassador, author and maintainer of several open source projects you may have heard of, Goldilocks and Pluto. Stevie is also, she won't say it out loud, but she's the author and maintainer of another project we'll talk about later called Go No Go. And we're both longtime Kubernetes users and very excited to just always talk about anything open source and CNCF related.
Yeah, for sure. So our agenda for today is, or this evening, I'm not sure what time it is. We're going to first discuss why add-ons matter. We always talk about Kubernetes as a whole. We talk about add-ons individually in these sessions, but we don't generally address add-ons as like an ecosystem. So we're going to talk about add-ons, their purpose, and why they're important. We're going to talk about vulnerability trends, which is one of the main reasons that we're concerned about add-on security and upgrades. We're going to talk about the operational struggle, that which prevents us from upgrading our add-ons at a reliable cadence. And lastly, we're going to talk about best practices, and hopefully you all will leave here with some tools and ideas for how to manage add-ons in your clusters reliably and more diligently. And what is it you said, with a fire in your belly?
You said fire in your belly. I just want you all to be very excited to go back and upgrade all your add-ons.
That's right. It's a fire in your belly. All right, so why add-ons matter? What are they? Why do we have them? So let's start with like a tale of building a cluster. So you have an application you're very excited about, and you're like, I'm going to throw this in a Kubernetes cluster so that the world can experience my application.
That might have been your first mistake.
Throwing it into Kubernetes cluster. Yeah, we could do a whole talk about whether or not you should run your application in a Kubernetes cluster. But you've got, the ear and advice of trusted people who said, yeah, run this in Kubernetes. So that's what you're going to do. So you spin up a Kubernetes cluster, and you're just doing a baseline cluster to start off with, right? And so with the baseline cluster, what you're going to get is basically your control plane, right? So that's all the components that control the cluster, that schedule your workloads on nodes, that reconcile the state of the cluster as it is with what you want it to be, that stores that state. And you're going to have your data plane, which is where your worker nodes live, where your actual workloads are going to run. And that data plane is going to have components that control or facilitate communication between the data plane and the control plane. And also, components that deal with the underlying container runtime on the nodes. In addition, you're going to have some components running in the cluster that facilitate traffic between pods across nodes. And you're also going to have components running that enable service discovery. Now, as an aside, some of those components that I just mentioned are actually referred to as add-ons. But they're not really optional. Like, if you want your cluster to run and actually do things, to actually work, if you want to actually have your application run, you do have to have those particular add-ons installed. So it's kind of weird that they're called add-ons, but it is what it is. So at the end of the day, you have a baseline cluster running. You deploy your application to that baseline cluster. It's living there, it's happy, and you're like, great, now I want people to have access to it. I want to be able to expose it to people outside of my cluster. This is the first place, getting traffic into your cluster, where you start to consider add-ons. Now, you don't technically need add-ons, an add-on for this portion of it, right? You could use a Kubernetes a Kubernetes primitive, a service type of load balancer, right? But in the words of the great Bandit Healer, the father of Bluey Healer, it's simply not done, mate. That's a Bluey reference. I didn't do it with the Australian accent, but you know, that's that. So you don't do that. If you're running a production workload, you're going to deploy an ingress controller, or you're going to deploy some kind of gateway, and so that's your first add-on.
I just run all of mine on cluster IP and expose it to the world, right?
And then just update your IP addresses manually every time. Yeah, absolutely. That's one way to do it.
Don't do that.
Yeah, don't do that. So now you've got traffic coming into your cluster. You want to secure that traffic, right? You want to encrypt that traffic coming in, and maybe you want to encrypt the east-west traffic in your cluster as well, the traffic between your services. That's another place where you might start to consider add-ons, right? So you go and you choose an add-on to handle TLS. Now you've got traffic coming into your cluster, and you have that traffic being encrypted. Now you might want to know what's going on in your cluster. You might want to know how your application is performing. You might want to know how your cluster is performing. And if something is going awry, you want metrics that you can use to help troubleshoot that. That's the next place that you might want to look at add-ons in your cluster, right? So you're looking at observability, or considering observability add-ons. So here we are with like a baby Kubernetes cluster in its very infancy, and we've already got 3 to 4 add-ons that we've had to install just to get the basics going. And this is not where you stop. Like for a productionalized Kubernetes cluster, you are likely going to add many add-ons to your cluster to do all sorts of things. Add-ons, it turns out, are really important for realizing the potential, the true potential of Kubernetes. All the things that we talk about, the scalability, the reliability, the efficiency, the security, all of that typically hinges on these add-ons that you're going to install in your cluster. In addition, these add-ons are really important for helping us engineers be efficient in managing these clusters, so that we're not manually doing things like upgrading or updating DNS records or changing IP addresses and stuff like that, right? And for each of these add-ons, so here's a smattering of add-ons that are available in the ecosystem. For each of these, there are a bunch of options, right? So it's not just Nginx ingress controller. There's traffic and things like that. There's Kyverno, there's Keta, there's a horizontal pod autoscaler. There are lots of these, and these are meant to be managed, as you can see from this quote from the cluster add-ons GitHub page. These are meant to be managed in lockstep with your Kubernetes version, right? You upgrade Kubernetes, you upgrade these add-ons. They're meant to be seen as like a whole. And part of the reason for that is because if you're installing 10, 15 or more of these in your cluster, they have the capability to, if they get exposed, they have the ability to cause some real hurt for your cluster, right? So to sort of illustrate that, let's take a look at a set of permissions. This is an RBAC role for an add-on. I won't tell you which add-on it is.
Cert manager.
I won't tell you which add-on it is, but these are RBAC permissions, right? And this add-on has access to all the secrets in your cluster, right? It can create, update, all that stuff. And this is across namespaces. And we know what kind of secrets we can find in clusters sometimes, right? Database credentials are kept in secrets, certificate information is kept in secrets. So if this add-on, whichever it is, gets compromised, this could be a very bad day for you.
I should be nicer to cert managers.
You should be nicer.
They need those permissions.
They need these permissions.
There's reasons for that. You can't segment access to secrets, but.
Right, but this is, I didn't say this was cert manager, so I'm just gonna move on. So another example of permissions that could be harmful, right? This is a security context from a container from a different add-on. And in this security context, we see that it adds capabilities, sysptrace and sysadmin, right? These capabilities mean that a process can interfere with another process. It can retrace information which could leak sensitive data potentially. It means that it could enable a container to break its isolation boundaries. It means that the process of the container could mount and unmount file systems. It could load and unload modules from the kernel, right? On top of that, privileged is set to true, and privileged true is essentially like running root. It's all the Linux capabilities, including these two that are drilled out here, right? So we've got access to host networking, namespaces, the ability to circumvent tools like AppArmor and SE Linux. Again, a very bad day if this gets exposed. So what this illustrates is that you have a number of these add-ons running in your cluster that potentially have these kinds of permissions. So that means that like if there's a vulnerability that is exploitable, you could be in a lot of trouble. So the two ways that you try and subvert that or try and address that as an engineer is first, you want to be aware of what's running in your cluster, what permissions they have, and if there are options for adjusting those permissions, if you can change the RBAC settings, for example, you can do that. You can't always do that though, because some of these add-ons need those permissions, as Andy said, right? If you have an add-on that uses eBPF under the hood, it's going to need kernel access, it's going to need host networking. So the next best thing is that you're staying on top of these add-ons so that you're patching them so that when vulnerabilities are released, you're on top of it and you can say that you have the latest patched versions of these things running in your clusters, because vulnerabilities aren't going anywhere.
No, they're not. So as Stevie said, these add-ons exist in all of our critical paths. North, south, east, west traffic, secrets management, all of these add-ons have all the access to all of our cluster functionality. And the vulnerabilities that are out there in open source are only getting worse. As our adoption of open source continues, we see here from the Black Duck Open Source Security and Risk Analysis Report, 86% of software that was shipped that Black Duck analyzed contained vulnerable open source. Now, this is about the software supply chain. It's not directly about add-ons, but I believe that these two go hand in hand, and a lot of what we see in that supply chain also affects our add-on supply chain. And so what we also see is that in the 10 years that Kubernetes has existed, we're seeing a lot more CVEs reported.
It's a big number.
That's a huge number. That's, if you've watched your trivia reports or you have a vulnerability scanner running, you've seen this 463% growth in the number of CVEs over the last 10 years. This is a Sonatype report that was released last year, looking back 10 years. In addition to that, because of the volume, we're getting slower at remediating them. So if you look back 10 years ago, we've got 30, 40, 50-day release or remediation times for all these vulnerabilities. You fast forward to 2024 when this report came out, and we're looking at over a year to remediate a lot of these CVEs. And so as cluster operators, what we're seeing is a ton of pressure from the supply side of vulnerabilities in all of the software that we're using.
We're getting notifications for CVE remediations from 2024, like this week. We had a bunch that got released, and it's like, okay, now we're fixing these things, and it's very old, so still happening.
Yep, absolutely. And on the flip side of that, so we have increasing pressure from the supply side of vulnerabilities, we have increasing pressure from the regulatory side to fix all of these things. And so we have multiple frameworks and executive orders that all point towards us needing to spend more time working on patching our vulnerabilities. So we've got the executive order signed in 2021. It doesn't have a direct CVE requirement, but it does require publishing SBOMs and formalized incident response, which can both be observed to be pointing in the direction of patch management over time. We have the Cyber Resilience Act in the EU, which is adopted in 24, expected to be enforced in the next couple of years, that requires a formal process for mitigating and patching CVEs. The NIST cybersecurity framework was updated last year to include v2.0, which also includes detailed CVE response as a requirement and publishing SBOMs of the software that you're shipping, including open source vulnerabilities or dependencies that may have vulnerabilities. And it also recommends proactive patching. And then again, ISO 27001, similar requirement. So we have a lot of regulatory pressure across all the different bodies that might be regulating the software that we're building to be patching our dependencies and our infrastructure components, while we're also seeing the supply side of vulnerabilities go up. So as cluster operators, we're kind of stuck in this very difficult spot in the middle where we have pressure from both sides. Stevie's going to talk a little bit more about that.
So Why is it so hard for us to maintain these add-ons? Why is it so difficult for us to upgrade them on a reasonable cadence? It's because the struggle is real. And I think one of the best ways to sort of think about it and visualize it is to think about where we've come with Kubernetes upgrades. Because we used to be very much in a similar position with upgrading Kubernetes as a whole, right? So in the beginning, it was not unusual for an engineer to deploy, their Kubernetes cluster and then leave it there at that version. If everything was running fine and there were no new things that people needed, new features that were necessary in your company, you would let that cluster ride for as long as you could. Why? Because upgrading is scary and Kubernetes is complex. Remember the Kubernetes 1.5 migration when you had to change etcd? Back then, we didn't have things like a Valero that did, snapshotting backups of your cluster for you and easily, right? If you were backing up your cluster at all, and let's face it, most of us were not, you were running some kind of script that was using etcd CLI commands to do it, you probably weren't testing it, you probably weren't testing restoring your backups, and so you definitely didn't feel secure being like, okay, well, if something goes wrong, if we bork our clusters and during this migration, we can restore it. You probably didn't have that confidence, right? And so a lot of people stayed on their older versions of Kubernetes as a means of not having to go through this upgrade. Lots of folks, my company at the time included, just spun up brand new clusters and migrated our workloads over because we felt like that was the easiest path to go through.
We took the more fun route of just taking down the whole control plane all at once so that we could upgrade etcd and let the workloads keep running.
Oh, you guys are living the risky life.
It was exciting.
So yes, it's scary. A small mistake can absolutely destroy your cluster and make things very bad for you. In addition, Kubernetes is complex. There are a lot of moving parts, a lot of pieces, and sometimes they're not even about Kubernetes itself, but the things that use Kubernetes. So if you wanted to upgrade to one of these versions, you had to go through your code base, and you had to find the things that were using those API versions, and you had to change them. And actually, probably a lot of you weren't doing the actual changing, right? Because you're not generally, engineers, SREs aren't generally managing the deployments, the application side of things to the cluster. You're chasing down developers now and trying to get them to upgrade their manifest and redeploy these things so that you can do these upgrades. And developers probably didn't really want to deal with that because they didn't understand why, right? They don't know the urgency, the operational urgency behind doing this, right?
I love chasing down developers and asking them to do things.
I'm sure they love having you chase them down too,
so much
probably. So it's a good relationship. Yeah. So this is part of the reason that is so hard, that it had been traditionally so hard to upgrade Kubernetes. But now, according to this 2023 Datadog report, it looks like we are gaining velocity on keeping our versions of Kubernetes up to date. There's about 50% of people, well, let me first ask, in this room, if you don't mind, how many of you are running clusters right now that are older than like 1.30, let's say? Great, so that's exactly what I expected, right? It is easier to upgrade clusters now, and more people are upgrading newer versions. So again, this graph shows that in 2023, 50% roughly of people were running clusters that were 16 months old or younger or newer, right? So people are upgrading their clusters with more velocity. Why? What has changed? Well, one of the things that I'd wager is that more people are using cloud service providers for their Kubernetes clusters, right? Here, according to this CNCF survey from 2024, 46% of people are using cloud service providers for their Kubernetes. So that's your EKS, your GKE, your AKS, right? And why does that matter? Because they want you to upgrade. And they're not going to often give you a choice. These providers do automatic control plane upgrades. They drag you along, kicking and screaming to newer versions of Kubernetes, whether you like it or not.
And sometimes they don't even tell you.
And sometimes they don't even tell you. GKE will just whoop right out from under you. Oh, look, you're running on a new version of Kubernetes. EKS will allow you to run older versions of Kubernetes if you insist. It's going to cost you money. And then you're going to have to explain to your CFO, your director of engineering, or whatever, why your AWS bill is going up. So that's incentive for you to move along with the upgrades as well. So given this story of Kubernetes and how we've moved along and gotten to a good pace with upgrading the versions of the cluster themselves, why do we still struggle with add-ons, right? What is the barrier to reaching that same kind of velocity with the add-ons in our clusters? Set it and forget it. So first of all, these are all bullet points, sort of, with the little icons, but these are all interrelated points. They all feed into each other. It's one big story to start off with. Set it and forget it syndrome is very real. I would wager that everybody in here at some point has deployed some application or something and then just moved away from it, moved along. As long as it's not broken, as long as it's not causing any headaches, as long as it's doing what it's supposed to do, much like our old Kubernetes clusters, we just leave it alone. What is the appeal of doing that? Why do we have that? Well, first of all, we've got a lot of stuff to do, right? So if it ain't broke, don't fix it. Also, these things can have complicated compatibility requirements. So upgrading them isn't like a simple thing. It's not a straightforward path all the time. Some add-ons require certain versions of Kubernetes. So you may go to update an add-on and realize that, oh, it's going to require you to actually update your cluster as well. And you're not ready for that. That's a problem. Also, sometimes these have the tendencies on things around them that are not even related to the add-on that you have to address. I don't know if you all remember, I think it was a couple of years ago, Cert Manager had an upgrade, not to pick on Cert Manager.
Yeah, why do we do that?
But Cert Manager had an upgrade where they changed their annotations. They changed it from cert-manager.io to certmanager.io or something like that. And when they did that, that required all the ingress objects in your cluster to be updated to reflect those new annotations. Because if you didn't, then the next time your ingress, if you're using the Nginx, if you're using the shim that installs the certificates for you, when you go to renew your certificate, it failed. When you deployed something to your environment to get a new certificate, it would fail, right? So that's a whole lot of work in addition to just upgrading Cert Manager that you weren't prepared for as an engineer, right? The upgrade process is manual. You have to read release notes. Even if you're using GitOps, like Argo CD or Flux, you have to read through these release notes. You have to review these breaking changes. And they're not all in the same place. We just did this example story where you've got maybe 5 add-ons in your cluster. That's 5 different places that you have to go check to see what the changes are. And there's no standardization, so you may be looking through change logs on GitHub, you may be looking through PRs. Or you may be looking at a website that has a nice bulleted list of changes, right? It's homework that you have to do, and it's not easy. You have to test because we all, of course, know that we deploy in lower environments before we go into production. None of us are deploying straight to production, right?
We do?
Uh-huh.
I thought we tested in prod.
No. So we're testing, and then we have to figure out how to roll these things back if they don't work. And that's not always simple, especially when you're dealing with custom resource definitions, for example. And this all culminates in time. You need time to do these things. And we don't often have time. We don't often have those cycles to dedicate to this sort of thing. Right?
I do.
Well, that's because you're a CTO. So, what is the solution? How do we address this? How do we move forward? How do we get add-ons in the same space that we have the Kubernetes versions right now for upgrades?
It's a great question. The easy answer is just hire us, but this isn't a pitch. So, I love this quote. This goes way back to the earlier days of DevOps. This is from the Continuous Delivery book. A fellow engineer said this to me years ago, and it's been kind of my mantra for a long, long time. If it hurts, do it more often and bring the pain forward. Divide it up into smaller chunks, do it sooner, do it more often, and then it will stop hurting so much. So I'll extend this a little bit to say, just like we would strive to release our software continuously, that's kind of the holy grail, we've been talking about it for a long time, we should also be patching our infrastructure. All of these underlying pieces, all of these add-ons need to be done, need to be kept up to date along with everything else that we're doing. And there's tooling that can help with that. Stevie said that there's a lot of time that goes into all of these different processes. There is tooling that can help take away some of the time required to do this. And there's a few things here that we're also working on for the future in our open source. So Fairwinds has several open source projects. Pluto specifically will help you discover where you're using those removed API versions. You can build that into your CI/CD pipeline that maintains your infrastructure as code so that when deprecated versions come up, you're fixing them now instead of fixing them later when you go to do updates. Nova can help let you know when certain things in your cluster are out of date. And then Go No Go, the tool that Stevie wrote and we're continuing to work on, is designed to help encapsulate all of the research and findings that you put into discovering how these upgrades are going to go into a machine-readable format that we can then apply to all of our clusters across all of our environments and understand what work needs to be done to do the upgrade. And so that's an area where I think we'll see some additional development over the next couple of years. If you want to just fully automate the thing and let it update on its own and then deal with what breaks afterwards, you can use something like Renovate. There are strategies to make that less painful and not take down your production environment. That can be a very useful pattern for you to just automatically update your non-production environments, see what breaks, fix everything, and then roll the updates out to production. I've definitely seen that strategy work for some folks. Tools like Dependabot's similar to Renovate, that can help you just see what updates need to occur and automatically generate pull requests into your infrastructure as code. And then if you also either don't have strict requirements or don't want to manage things, there are some available add-ons that can be managed by things like GKE Autopilot, EKS Auto Mode. They're limited in scope, they're also limited in configurability, and so it really depends on your needs, but they can remove some of the burden of updating your add-ons. So in summary, lots of research and analysis. Hopefully, we're hoping that AI might help us a little bit here in gathering and collating all of those release notes from all those various sources. That's something that we're hoping to build into Go No Go potentially in the future. Tooling and automation to reduce the amount of time that it takes to do some of these changes so that you can spend your time focusing on making sure stuff doesn't break. Do it more often. I think this is honestly the most important thing. We update every single add-on in every single cluster that we have every month. It is time consuming, but once you get into the pattern of doing it, you have a standardized pattern for doing it, it becomes relatively easy.
Yeah, the last thing you want to do is have some sort of really severe vulnerability come out and you need to patch to a certain version and you're many versions behind, because that's more painful and more likely to introduce some breaking changes for your environment. So
absolutely,
increased frequency is definitely a big one.
Yeah, for the foreseeable future, unless you're paying ChainGuard a vast amount of money, your security updates and your feature updates are going to be tightly coupled with all of these open source tools. And so we have to just keep them up to date and move forward with them, just like we've started doing with our Kubernetes clusters. And then, of course, I think we've said it multiple times, use a staged approach. Don't do your testing in prod, please. That's really all I have there.
So that's our talk. Thank you for your time. Really appreciate you. And I think we have a minute left. So if there are any questions,
we're happy to take them. Also,
comments, flatteries. You look very nice today, Stevie. Thank you. All right. That's it.
Thank you.